Today we're going to be talking about how to find the point where the line intersects the plane. And in this particular problem, we've been given the equation of a line in parametric form, and then we have an equation in the form x minus y plus 2z is equal to 9, which defines the plane. So we have the parametric equation of the line and then the equation of the plane. We need to figure out where this line and this plane have a point of intersection. So the way that we're going to do that is by plugging the values that we have here, the parametric equations. We're going to plug those equations into our equation for the plane. That's going to reduce this equation so that it's only in terms of the parameter value t. Then we should be able to solve for a value of t. That'll be the value of the parameter where the intersection occurs. So here's what that looks like. We have x equals 3 minus t. We're going to plug 3 minus t into the equation of the plane for x. So instead of x right here, we're going to plug in 3 minus t. Then for y, we're going to plug in 2 plus t. We have this negative sign here, which we need to make sure we distribute. So let's go ahead and say minus, and then in parentheses here, we'll put 2 plus t. Then for z, we've got this coefficient of 2, so we'll leave that there, and plug in 5t for z, like so. We set that equal to 9. Now notice that instead of variables x, y, and z, we only have the t variable in this equation. T, of course, is the parameter value. We want to solve for a value of the parameter where the intersection occurs. So we're going to get 3 minus t. When we distribute this negative sign, we'll get minus 2 minus t. 2 times 5t is 10t, so we'll get plus 10t is equal to 9. Now we want to consolidate our t values and our constants. So here on the left-hand side, we have minus t plus 10t. That's going to give us 8t. On the left-hand side, we want to consolidate our constants on the right. So we have 3 minus 2, which is equal to 1. We want to go ahead and subtract 1 from both sides, which will cancel the constants on the left. We'll be left with a value of 8 on the right-hand side. So 8t is equal to 8. Dividing both sides by 8, we get t is equal to 1. This is the value of the parameter where the intersection occurs between the line and the plane. Now, in order to find a coordinate point in terms of x, y, and z where the intersection occurs, all we need to do is plug this parameter value into the parametric equations of the line. That'll give us values of x, y, and z that we can plug into our coordinate point. So here's what that looks like. Let's say we plug in 1 for t as the parameter value. We'll get x is equal to 3 minus 1, or x is equal to 2 here. We'll get y is equal to 2 plus 1, or y is equal to 3, and we'll get z is equal to 5 times 1, or z is equal to 5. So this becomes now our coordinate point 2, 3, 5, where the intersection occurs. All we need to do, just to verify that we did everything correctly, is plug this coordinate point into the equation of the plane. If this coordinate point satisfies this equation, then we know that we've done it correctly and we have a true point of intersection. So let's just go ahead and plug in 2, 3, 5. What we'll get here is 2 minus 3 plus 2 times 5 is equal to 9. When we simplify, we get 2 minus 3 plus 10 equal to 9. 2 minus 3 is a negative 1, plus 10 is a positive 9, so we get 9 equals 9, and we can say that that is true. What that tells us, the fact that we got 9 equals 9 here, tells us that the point 2, 3, 5 is a point that lies in this plane. So we've proven that the point lies in the plane. We know that this point lies along the line defined by these parametric equations because we set t equal to 1 and we got this coordinate point out. So when t is equal to 1, the coordinate point on this line is 2, 3, 5. So we know this point lies on the line, we know it lies in the plane, and because it's in both, we know that 2, 3, 5 is a point of intersection between the line and the plane.